Good afternoon, students. So, welcome to my online classes. After a long time, I am taking your class. How are you? I hope you are fine and doing well. How is your study? Are you writing the notes? What about your doubts? So, if you are having any doubts regarding earlier chapters, means you can message me. So, from today onwards, I will be always with you for solving the doubts. Right, see, in the last class, I started photoelectric effect, the concept of photoelectric effect. That is, I started the chapter dual nature of radiation and matter. Dual nature of radiation and matter. And see, in that chapter, what you learned about electron emission and types of electron emission. Electron emission means it is the process of emission of electrons from a metal surface. The process of removal of electrons or emission of electrons from a metal surface is called electron emission, and there are three types. Actually there are four types, but for your syllabus only three types are mentioned. Those three types are first one is thermionic emission, field emission, photoelectric emission, and secondary emission. So what is thermionic emission? If the electrons are emitted or if the electrons are removed from the metal surface by means of heating, that process is called thermionic emission. And if the electrons are emitted from the metal surface by means of electric field, by providing a strong electric field, that process is called field emission. And if the electrons are emitted from the metal surface by sending a light of particular frequency, that is called photoelectric emission. And I started photoelectric effect in detail, and you learned experimental study of photoelectric effect. So in photoelectric effect, experimental study, it involves an evacuated glass tube. It is consisting of an evacuated glass tube, and which involves inside the evacuated glass tube there are two metal plates. One is C is emitter plate. A is collector plate. C is emitter plate. Yes, what it is called? C is emitter plate. C means emitter plate. A means collector plate. So here this is the source of radiation, and this is the rays of light. Rays of light, they are made to fall on the cathode plate or emitter plate. As soon as the light falls on the cathode plate, electrons are emitted from the cathode plate, that is emitter plate, and they start moving towards the collector plate. The electrons which are emitted from the emitter plate, that is C, they start moving towards anode plate or collector plate, and they are collected by the plate A. And these are called photoelectrons. These are called photoelectrons, and they constitute what is the flow of photoelectrons from emitter plate to collector plate constitutes what is known as photoelectric current. So in this class, and this effect is photoelectric effect, and in this class I am discussing effect of intensity effect of intensity on photoelectric current. See, effect of intensity on photocurrent or photoelectric current. Photocurrent or photoelectric current. See here, what you are learning now? You are learning how the photocurrent. Photocurrent means the flow of photoelectrons from C to A, that they give rises to an electric current, that is known as a photocurrent. The flow of electrons is known as a current. So here the flow of photoelectrons from C to A, they constitute what is known as a photocurrent. So and in this concept you are learning how this photocurrent is dependent on the intensity of the incident radiation. So this is incident radiation. Incident radiation. So here intensity means energy of the light. Energy, how strong the light is. So here intensity, it represents strength of the light that you are sending to the cathode plate or to the emitter plate. See, what is the strength of the light? That is intensity. So here intensity means strength or energy of the light. See, one thing you try to remember, intensity, it increases the photocurrent. As you increase the intensity, photocurrent increases. So what it means? Photocurrent is directly proportional to it is directly proportional to intensity of incident radiation. Intensity of incident radiation. How means here? See, if I am sending a light of more intensity, then what happens? If I am sending a light of more intensity, then what happens here? Here the emitter plate, from the emitter plate, more number of electrons are emitted per second per unit area. So if you are sending a light of more intensity, more number of electrons are emitted from the plate C, that is emitter plate, and more number of electrons they flow from C to A. As when more number of electrons are flowing, the value of photocurrent increases. So here intensity is directly proportional to the photocurrent. As the intensity of incident radiation means light. As the intensity of incident radiation increases, the value of photocurrent also increases. So remember here, if the intensity is minimum number of electrons are removed from the plate C, and the value of photocurrent is minimum. If the intensity is maximum, ಅವತ್ತು ಬೆಳಕಿನ ಶಕ್ತಿ ಜಾಸ್ತಿ ಇದ್ರೆ, ಬೆಳಕಿಗೆ ನಾವು ಇಂಟೆನ್ಸಿಟಿ ಹೆಚ್ಚು ಕಡಿಮೆ ಮಾಡಬಹುದು. ಅದು ಜಾಸ್ತಿ ಇಂಟೆನ್ಸಿಟಿ ಇರುವಂಥ ಲೈಟ್ನ ನಾವೇನಾದರೂ ಕಳಿಸಿದರೆ, ಜಾಸ್ತಿ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ, ಜಾಸ್ತಿ ನಂಬರ್ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ರಿಮೂವ್ ಆಗ್ತವೆ. ಕಡಿಮೆ ಇಂಟೆನ್ಸಿಟಿ ಕಡಿಮೆ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ರಿಮೂವ್ ಆಗ್ತವೆ. ಕಡಿಮೆ ಎಲೆಕ್ಟ್ರಾನ್ ಅಂದರೆ ಕಡಿಮೆ ಫೋಟೋಕರೆಂಟ್, ಜಾಸ್ತಿ ಎಲೆಕ್ಟ್ರಾನ್ ಜಾಸ್ತಿ ಫೋಟೋಕರೆಂಟ್. So the variation of photocurrent versus intensity is given by this graph. Here intensity of light is taken along x-axis. Intensity of incident radiation. Intensity of incident radiation. It is taken along x-axis, and say along y-axis. Here here photocurrent. Photocurrent is taken along y-axis. Photocurrent right? So it is directly proportional. As I told you, if the intensity of the light is maximum, photocurrent is maximum. If the intensity is minimum, photocurrent is minimum. So here photocurrent, photoelectric current, it means number of photoelectrons flowing from emitter plate to collector plate. So more number of photoelectrons means more value of photocurrent. So when more number of photoelectrons are emitted, when the number of electrons emitted are maximum, if the light is having maximum intensity. So here intensity is direct intensity of the incident radiation. It is directly proportional to photocurrent. Intensity of the incident radiation is directly proportional to the photocurrent, right? So next one, see, next I am discussing the second one, effect of potential on photocurrent. Effect of potential on photocurrent. See here C is emitter plate, A is collector plate, C is emitter plate. C is what? C is emitter plate. Emitter plate, it is initially here in this diagram. It is negative. It is having negative potential. Although C is having, this one is having negative potential, and A is called collector plate. A is called collector plate, and this A is having the positive potential. A is having positive potential. So here C is a emitter plate, it is having negative potential. A is a collector plate, it is having positive potential. So in the experimental setup, here C is called emitter plate and A is called collector plate. C is having negative value of electric potential. A is it is set up with positive value of electric potential. So here, see, for one more reason, see why the electrons are emitted from this plate C. Why it is called emitter plate means it emits electrons. Why the electrons are emitted? See, when the light is falling on the plate C, here the electrons inside the plate C, they absorb the energy of the light which is falling on it, and by absorbing the energy, the electrons are removed, the electrons are emitted out. So, and another reason is C is having negative potential. So and electrons are having a negative charge. Negative means it repels. So for that reason also here the electrons are repelled from the plate C and they are attracted towards the plate A, because plate A is maintained with the positive potential. So plus charge. So here electrons are negative charge. Negative, positive, there exists a force of attraction. So the electrons are moving and they are collected by the plate A. So therefore, as the plate A is collecting the electrons, it is called collector plate. So if the positive potential of the plate A is increased, so here photoelectric current increases. What I am telling is positive potential of plate A. Positive potential of plate A is directly proportional to photocurrent. It is directly proportional to photocurrent. So if this plate is made to have more value of positive potential, or if the positive value of potential is increased to the plate A, then photocurrent increases, because see what I am telling is it collects more number of electrons. If the value positive potential value is increased in A, it starts collecting more number of electrons and more value of photoelectric current flows. And see, as you go on increasing the positive potential of A ಗೆ electric potential value positive ನಲ್ಲಿ ಮೇಂಟೈನ್ ಮಾಡಿರ್ತಾರೆ, C ಗೆ ನೆಗೆಟಿವ್ ನಲ್ಲಿ ಮೇಂಟೈನ್ ಮಾಡಿರ್ತಾರೆ. ಆ A ಗೆ ಪಾಸಿಟಿವ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇರೋದ್ರಿಂದಲೇ ಅದೇನು ಮಾಡುತ್ತಾ ಎಲ್ಲ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಗಳನ್ನ ಅಟ್ರಾಕ್ಟ್ ಮಾಡಿ ಕೊಡ್ತಾ ಇರ್ತದೆ. So ಇಲ್ಲಿ more number of electrons are collected by the plate A and more value of photoelectric current flows in the tube ಇಲ್ಲಿ ಇದರೊಳಗಡೆ. So here for a particular value of positive potential, for a particular value of positive potential, the value of photoelectric current becomes higher and it fixes or it remains to a constant value. ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗ್ತದೆ ಕರೆಂಟ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗಿ see if the graphical representation, this is the graphical representation. See here collector plate potential, here we shall take collector plate potential. Collector plate potential is taken along x-axis, and here this is photo current. So as the value of collector plate potential, I mean positive value of potential given to the plate increases, current increases, photo current increases. Photo current increases and remains same after some time. Say if you are increasing the potential of A, the current will not increases, current remains to a fixed value. This fixed value of current is called saturation current. Saturation current. This is called saturation current. So saturation current. So after that current is not increasing, photo current, I mean all the electrons. Here saturation current means complete ಎಲ್ಲ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಇದರಲ್ಲಿ ಬಂದು ಕರೆಕ್ಟ್ ಆಗ್ತವೆ. So there are no more electrons to come from C to A. All the electrons have been collected by the plate A. So this is the case where you get saturation current. What is saturation current? It is the maximum value of current. It is the maximum value of photoelectric current developed inside the glass chamber or inside the glass tube for a higher value of positive potential given to the plate A. For a higher value of positive potential given to the plate A. So now for time being we shall discuss another thing. Here now I am reversing the polarity. Now I want to reverse the polarity. It means C is initially negative potential. Now C is made to have positive potential. C is made. C na positive potential adjust ಮಾಡಿ positive potential. Now adjust the plate C to positive potential and A to negative potential. A negative potential. Plate A negative potential. Now the polarity of the two plates is reversed. Now initially C negative ittu, A positive ittu. ಈಗ C ನ positive ಮಾಡಬೇಕು, A ನ negative ಮಾಡಬೇಕು. ಏನಾಗುತ್ತೆ? See when plate A is having a negative potential, first of all here if it is having negative potential means electrons they starts repelling from the plate A. They starts repelling. Attraction ಆಗಲ್ಲ, repulsion ಆಗಲ್ಲ ಸ್ಟಾರ್ಟ್ ಆಗ್ತದೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದರಿಂದ. ಇದು ನೆಗೆಟಿವ್ ಆಯಿತು ಅಂದ್ರೆ if the polarity of the plate A is changed, ಅದು ಯಾವಾಗಲೂ ಪಾಸಿಟಿವ್ ಇರಬೇಕು. Always it should be with positive potential and this should be with negative potential. If you are reversing the polarity, if the potential is reversed, if the plate C is said to have negative potential and positive potential. First of all, negative iruttada, idu positive, idu negative aaytade enagutte immediate enaguttade iga all the electrons they are not attracted by the plate A. Now they are repelled from the plate A. Now they start repelling, dura hogoke start madtavo. So the number of electrons which are coming towards the plate A decreases. ಈಗ ಪೊಟೆನ್ಷಿಯಲ್ ಏನಾದರೂ ರಿವರ್ಸ್ ಮಾಡಿದ್ರೆ ಈಗ ಏನು ಹೇಳಿದ್ರೆ ನಾವು see positive potential of plate A is directly proportional to photo current, but negative potential of photo current ಏನಾಗುತ್ತೆ negative potential of plate A, it is inversely proportional to photocurrent. So now photocurrent decreases because the number of electrons that are attracted towards the plate A now decreases. Very less number of electrons they are attracted by the plate A now, and those electrons are highly energetic electrons. Only highly energetic electrons are attracted by the plate A and they reach the plate A and they are collected by the plate A, and most of say 99% of the photoelectrons they are not moving towards the plate A because of change in the polarity of the plate A. Now plate A is having negative potential. So here negative potential of plate A is inversely proportional to photocurrent. So if the plate A is made to have negative potential, photocurrent decreases. So see, now imagine you are increasing the negative potential of plate A. For a particular value of negative potential given to the plate A, electrons reaching to the plate A becomes completely zero. The number of electrons which are moving from plate C to plate A, they becomes zero. I mean no more electrons are moving towards the plate A. So that and with say at that value of negative potential, photoelectric current becomes zero, photocurrent becomes zero, and the particular value of negative potential for which the photocurrent becomes zero. Photocurrent ಯಾವಾಗ zero ಆಗುತ್ತೆ ನೋಡೋಣ. ಒಟ್ಟ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ಗಳು A ಕಡೆ ಹೋಗಲಿಲ್ಲ ಅಂದ್ರೆ photocurrent zero. ಆ C ಇಂದ A ಕಡೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಮೂವ್ಮೆಂಟ್ ಆಗೋದೇ photocurrent. ಈಗ ಕಡಿಮೆ ಹೋಗ್ತಾ ಇದ್ರೆ ಕಡಿಮೆ ಆಯಿತು, ಒಟ್ಟ ಹೋಗಲೇ ಇಲ್ಲ ಅಂದ್ರೆ ಹೋಗ್ತಾನೆ ಇಲ್ಲ ಅಂದ್ರೆ ಏನಾಗ್ತದೆ, photocurrent ಏನಾಗುತ್ತೆ zero ಆಗುತ್ತೆ. Photocurrent becomes zero. So here photocurrent becomes zero means this is called negative for negative minus VO. The stopping potential ಅಂತ ಕರೀತಾರ. That is called stopping potential. What is stopping potential? Stopping potential is the particular value of negative potential. Stopping potential is the particular value of negative potential. Vs ಅಂತ ಬರೋಣ. Vs stopping potential. Vs what is stop ಮಾಡೋದು ಅಂದ್ರೆ ಸ್ಟಾಪ್ ಮಾಡುವಂತ ಪೊಟೆನ್ಷಿಯಲ್. ಏನು ಸ್ಟಾಪ್ ಮಾಡೋದು? ಫೋಟೋ ಎಲೆಕ್ಟ್ರಾನ್ಗಳನ್ನು ಸ್ಟಾಪ್ ಮಾಡುವಂತ ಒಂದು ಪೊಟೆನ್ಷಿಯಲ್. So here stopping potential is the particular value of negative potential given to the plate A for which photocurrent becomes zero. ಯಾವ ಈಗ ನಾವು ಹೇಳಿದ ಫಸ್ಟ್ ಇದು ನೆಗೆಟಿವ್ ಮಾಡೋಣ, ಕಡಿಮೆ ಆಗ್ತಾವ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಈ ಕಡೆ ಬರೋದೇ ಇಲ್ಲ. ನೆಗೆಟಿವ್ ರಿಪಲ್ಷನ್ ಉಲ್ಟಾ ಹೋಗ್ತಾವು, ಬರೋದಿಲ್ಲ ಈ ಕಡೆ ಬರೋಲ್ಲ ಅಂದ್ರೆ ಫೋಟೋಕರೆಂಟ್ ಕಡಿಮೆ ಆಯಿತು, ಇನ್ನೂ ಕಡಿಮೆ ಆಗ್ತಾವು, ಬರೀ ಭಾಳ ಎನರ್ಜಿ ಇರೋವು. The photoelectrons which are having a maximum energy, they still attracted by the plate A. ಅವು ಇನ್ನೂ ಅಟ್ರಾಕ್ಷನ್ ಆಗ್ತಿದ್ದಾವೆ ಈ ಕಡೆ. But if you increase the value of negative potential of plate A to higher values, ಜಾಸ್ತಿ ವ್ಯಾಲ್ಯೂಗೆ ಏನಾದರೂ ನಾವು ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದರೆ ನೆಗೆಟಿವ್ ಪೊಟೆನ್ಷಿಯಲ್ A ಪ್ಲೇಟ್ ಏನಾಗುತ್ತಾ, ಅವು ಹೈಲಿ ಎನರ್ಜೆಟಿಕ್ ಜಾಸ್ತಿ ಎನರ್ಜಿ ಇರುವಂಥ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಕೂಡ ಈಗ ಮತ್ತೆ ಈ ಕಡೆ ಬರಲ್ಲ, ಉಲ್ಟಾ ಬರಲ್ಲ, ಇಲ್ಲಿ ಬರಲ್ಲ, ಅಟ್ರಾಕ್ಷನ್ ಆಗಲ್ಲ. ಸೊ ವಾಟ್ ಇಟ್ ಮೀನ್ಸ್ ಫೋಟೋ ಕರೆಂಟ್ ಬಿಕಮ್ಸ್ ಕಂಪ್ಲೀಟ್ಲಿ ಝೀರೋ. ಸೊ ಯಾವ ಒಂದು ನೆಗೆಟಿವ್ ಪೊಟೆನ್ಷಿಯಲ್ಗೆ ಫೋಟೋ ಕರೆಂಟ್ ಝೀರೋ ಆಗುತ್ತೆ, ಆ ಒಂದು ನೆಗೆಟಿವ್ ಪೊಟೆನ್ಷಿಯಲ್ ಏನಂತ ಕರೀಬೇಕು ನಾವು, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್. ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್ ಈಸ್ ದ particular value of negative potential given to the plate A, given to the anode plate ಅಥವಾ plate A ಅಥವಾ collector plate. anode plate ಅಂತ ಕರೀತಾರೆ, collector plate ಅಂತ ಕರೀತಾರೆ. given to the collector plate A for which photo current completely becomes zero. For which photo current completely becomes zero, that is called stopping potential. And the way ಇಲ್ಲಿ the stopping potential ಏನು ಬರೆಯೋಣ ನಾವು, ಇಲ್ಲಿ see here I shall write one thing, this reason represents stopping potential. negative y axis and stopping potential. So imagine this is intensity I1. If I am repeating the experiment with light of another intensity I2. This is I3. So here strength of the light is varied. Strength of the light is different from I1. I1 is intensity. I2, I3 they are in intensity with different energies. ಇಲ್ಲಿ I1 ಗೆ ಕಡಿಮೆ ಎನರ್ಜಿ ಇದೆ, I2 ಜಾಸ್ತಿ ಇದೆ, I3 ಜಾಸ್ತಿ ಇದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. I3 is the strongest intensity compared to I2 and I1. So but their stopping potentials are same. That means see here stopping potential is not dependent. Stopping potential is not dependent on energy of the light which you are sending to perform photoelectric effect. Here this stopping potential it only depends on the potential. Stopping potential means it is not depends on frequency. It is not dependent. Frequency ಮೇಲೆ ಡಿಪೆಂಡೆಂಟ್ ಇರ್ತದೆ, ಮುಂದೆ ಬರುತ್ತೆ. ಇದು ಇಂಟೆನ್ಸಿಟಿ ಮೇಲೆ ಡಿಪೆಂಡೆಂಟ್ ಇಲ್ಲ. ನೀವು ಲೈಟು ಜಾಸ್ತಿ ಎನರ್ಜಿ ಇರೋದನ್ನ ಕಳಿಸ್ರಿ, ಕಡಿಮೆ ಎನರ್ಜಿ ಇರೋದನ್ನ ಕಳಿಸ್ರಿ, ಅದೆಲ್ಲ ಜಾಸ್ತಿ ಎನರ್ಜಿ ಇರೋದಂದ್ರೆ ಜಾಸ್ತಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬಂತಾವ ಅಷ್ಟೇ, ಕಡಿಮೆ ಇಂಟೆನ್ಸಿಟಿ ಕಡಿಮೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಬಟ್ ಇಲ್ಲಿ ಪೊಟೆನ್ಷಿಯಲ್ ಮೇಲೆ ಡಿಪೆಂಡೆಂಟ್ ಇದೆ. ಇದು ಪೊಟೆನ್ಷಿಯಲ್ ಉಲ್ಟಾ ಆಯ್ತಂದ್ರೆ ಇದೇ ನೆಗೆಟಿವ್ ಆಯ್ತಂದ್ರೆ ಏನು ಮಾಡ್ತಾವೆ, ನೆಗೆಟಿವ್ ರಿಪಲ್ ಉಲ್ಟಾ ಇಲ್ಲೇ ಹೋಗ್ಬಿಡ್ತಾವೆ. So here remember for the procedure repeated with different intensity of the light I1, I2, I3, here stopping potential is the same point. It is obtained at the same point. What it means, stopping potential is independent of intensity of incident radiation. See next one I am discussing third one, effect of frequency of incident radiation on effect of frequency of incident radiation on stopping potential. So see, in first case what you studied, how the photocurrent depends on intensity of the incident radiation. So photocurrent is directly proportional to intensity of incident radiation. That was your first concept. Next what you learned how the photocurrent varies with potential, how it is changing with respect to potential. So here when plate here, see how the photocurrent varies with potential means it entirely dependent on the potential of the plate A. If the plate A plate A is having a positive potential, then the photocurrent increases with respect to the potential. If the plate A is having a negative potential, photocurrent decreases and see it becomes zero for a particular negative potential given to the plate A, that is called retarding potential or stopping potential. In Kannada, stopping potential or this is also called as retarding decreasing retarding potential, and its symbol is VO, not VS, VO. VO is the symbol of retarding potential. And now you are studying effect of frequency of incident radiation on stopping potential. So as you know that light is having intensity, okay, no doubt the light is having intensity means strength of the light. Here frequency is the another factor. Frequency is related to color of the light. So frequency, wavelength, frequency means see in common saying frequency is how many rotations or how many number of waves, how many cycles are completed by the given wave in 1 second. Here light is a wave. How many rotations, how many cycles are completed by the wave in 1 second? That is called frequency. So here frequency means for photoelectric effect, the light that is sent to the plate C, that should have a particular frequency, and that frequency is called threshold frequency. That frequency is called threshold frequency. Nu naught is the threshold frequency. So here frequency is very important, because see for the more number of electrons emitted from the for emission of more number of electrons from plate C, you need more intensity for this light. Electrons ಜಾಸ್ತಿ ಬರೋದಕ್ಕೆ ಜಾಸ್ತಿ ಇಂಟೆನ್ಸಿಟಿ ಇರಬೇಕು. ಬಟ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಹೊರಗಡೆ ಬಂದಂತ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಗೆ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿನ ಯಾರು ಕೊಡ್ತಾರ? See, kinetic energy means it is the speed or velocity required for the photoelectrons to move from plate C to plate A. Plate C ಇಂದ plate A ಕಡೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಗಳು ಹೋಗೋದಕ್ಕೆ ಒಂದು ಸ್ಪೀಡ್ ಬೇಕು. kinetic energy that is provided. See, kinetic energy for the photoelectrons. Kinetic energy for the photoelectrons is provided. It is given, provided by frequency. Provided by the frequency of incident radiation. So remember here the energy required for the movement of the photoelectrons. The energy required for the movement of the photoelectrons from plate C to plate A. From plate C to plate A, that is given by the frequency of the incident radiation. If you are using more frequency, if you are using a light of more frequency, then there will be more energy for the photoelectrons to move from plate C to plate A. If you are using a light of less frequency, then the photoelectrons, they will have less kinetic energy, less speed, a minimum velocity to move from plate C to plate. Attraction irutte ಅಂತ ಹೇಳಿದ್ರಲ್ಲ ಸರ್ ಲಾಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ಲಿ. ಅಟ್ರಾಕ್ಷನ್ ಇರುತ್ತೆ, ಇಲ್ಲ ಅಂತ ಹೇಳ್ತಾ ಇಲ್ಲ, ಬಟ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಅನ್ನುವಂಥ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್, ಕೈನೆಟಿಕ್ ಚಲನಾವೇಗ, ಆ ಒಂದು ಫೋಟೋ ಎಲೆಕ್ಟ್ರಾನ್ಗಳಿಗೆ ಚಲನಾವೇಗ ಯಾವುದರಿಂದ ಬರುತ್ತೆ ಅಂದರೆ ಫ್ರೀಕ್ವೆನ್ಸಿಯಿಂದ ಬರುತ್ತೆ. ಸೊ ಮೋರ್ ದ ಫ್ರೀಕ್ವೆನ್ಸಿ, ಮೋರ್ ದ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. The photoelectrons will have So here kinetic energy, maximum kinetic energy, we call it as maximum kinetic energy. It depends on frequency of incident radiation. Frequency of incident radiation. So here I am going to draw a graph here. This is collector plate potential. Collector plate potential. Collector plate potential. This side, that is x-axis. Collector plate potential, and this one is y-axis. Y-axis here I am taking photocurrent. Same photocurrent. Photocurrent is taken along this direction, and retarding potential. Retarding potential. Retarding potential is taken this direction. Y-axis, negative x-axis. This is negative x-axis. So see here. Now you know that if the plate A is having positive potential, then photocurrent increases, right? Photocurrent increases. Imagine this is the light of intensity I1. So here as we increase the collector plate positive potential, more number of photoelectrons will reached by the plate A. They are collected by the plate A, and more value of photocurrent flows in the tube, right? So it means yes, after for a particular value of positive potential, the current increases and reaches to the saturation value. If it remains same after some time, or for a particular value of collector plate potential, the photocurrent remains same, or the photocurrent will not increase further. That thereby it is called saturation current. Saturation current. This is saturation current. This is the saturation current. Saturation current. If the same experiment, see here. So if you reverse the polarity, now if you reverse the polarity, the number of photoelectrons which are traveling from C to A decreases, and after some time, for a particular value of negative potential given to the plate A, here the photoelectrons becomes 0. The number of photoelectrons becomes 0, and the photoelectric current becomes 0. That particular potential is called retarding potential. So this is the retarding potential. Say for example, V01 minus V01, V01, right? And here frequency is nu 1. Frequency is nu 1. If the same experiment is conducted, with light of another frequency nu 2, which is somewhat greater than this one. ಸ್ವಲ್ಪ ಇದರಲ್ಲಿ ಜಾಸ್ತಿ ಇದ್ರೆ ಅವಾಗ ಏನಾಗುತ್ತಾ, now you need see, now I am using another frequency for the light radiations. So another frequency of the light radiations, so this is nu 2 is greater than nu 1, and now the electrons they will have more kinetic energy. ಗೊತ್ತಿದೆ frequency ಅನ್ನೋದು kinetic energy ಗೆ ನೇರವಾಗಿ ಡಿಪೆಂಡೆಂಟ್ ಇದೆ. ಈ frequency ಜಾಸ್ತಿ ಆದರೆ kinetic energy ಜಾಸ್ತಿ ಆಗ್ತದೆ. kinetic energy ಅವು ಫೋಟೋ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಎನರ್ಜೆಟಿಕ್ ಆದವು. ಫೋಟೋ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಎನರ್ಜೆಟಿಕ್ ಆಯಿತು ಅಂದ್ರೆ ಇದಕ್ಕೆ ನೀವು ಕೊಡುವಂತಹ ನೆಗೆಟಿವ್ ಪೊಟೆನ್ಷಿಯಲ್ ಏನಾಗ್ತದ, ನೆಗೆಟಿವ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇನ್ನೂ ನೀವು ಜಾಸ್ತಿ ಮಾಡಬಹುದು. So you need to increase the retarding potential. You need to give more value of negative potential to the plate A so that electrons are repelled from the plate A. ಈಗ ಏನು ಫ್ರೀಕ್ವೆನ್ಸಿ ಜಾಸ್ತಿ ಮಾಡಿದಂಗೆಲ್ಲ ಇವುಗಳಿಗೆ ಶಕ್ತಿ ಜಾಸ್ತಿ ಆಯಿತು. ನೆಗೆಟಿವ್ ಇದ್ರೂ ಕೂಡ ಇವು ಹಂಗೆ ಬರ್ತಿರೋದು, ಸ್ವಲ್ಪ ಹಂಗೆ ಮುಂದಕ್ಕೆ ಹೋಗ್ತಿರ್ತಾವೆ. ನೀ ಇದ್ರದ್ದು ಇನ್ನೂ ಜಾಸ್ತಿ ಮಾಡಬೇಕಾಯ್ತವ. ಸೊ ಅದರ ಅರ್ಥ ಏನಿದೆ, ಇದು ಮೈನಸ್ as we increase the value of frequency, stopping potential also increases. If the nu 3 frequency nu 3 this is minus VO3. ನಾನು ಏನು ಹೇಳಿ ಒಂದೇ ಮಾತನ್ನು ಹೇಳೋದಂದ್ರೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅನ್ನೋದು ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್ಗೆ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಅದು. ನೀನು ಹೈಯರ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇರುವಂಥ ಲೈಟ್ನ ತಗೊಂಡು ಇಲ್ಲಿ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಫೆಕ್ಟ್ ಏನಾದರೂ ಕಂಡಕ್ಟ್ ಮಾಡಿದೆ ಅಂತ ತಿಳ್ಕೊ, ಅವಾಗ ಅಲ್ಲಿ ಬಂದಿರುವಂಥ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಜಾಸ್ತಿ ಎನರ್ಜಿ ಇರ್ತಾವೆ. ನೀವು ಅವಾಗ ಇದಕ್ಕೆ ನೆಗೆಟಿವ್ ಪೊಟೆನ್ಷಿಯಲ್ ಜಾಸ್ತಿ ಕೊಡ್ಬೇಕು ನೀವು, ಅಂದ್ರೆ ರಿಪೆಲ್ ಆಗ್ತವೆ. ಅಂದ್ರೆ ನೀವು ಇದ್ರಲ್ಲಿ ನಾವೇನು ಹೇಳ್ತೀವಿ ಈಗ ನೀವು ಎರಡು ಥರ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಬೋದು. ವಾಟ್ ಈಸ್ ದ ಎಫೆಕ್ಟ್ ಆಫ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ಇನ್ಸಿಡೆಂಟ್ ರೇಡಿಯೇಷನ್ ಆನ್ ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್? See here, frequency of incident radiation it varies inversely with the stopping potential. So for see ಇಲ್ಲೇ ಗೊತ್ತಾಗುತ್ತೆ ನೋಡಿ, ಇದು ಫ್ರೀಕ್ವೆನ್ಸಿ ಜಾಸ್ತಿ ಆದಾಗ ನೆಗೆಟಿವ್ ಪೊಟೆನ್ಷಿಯಲ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ನೆಗೆಟಿವ್ ಪೊಟೆನ್ಷಿಯಲ್ ಜಾಸ್ತಿ ಕೊಡಬೇಕು ನೀವು ಸ್ಟಾಪ್ ಮಾಡೋದು, ಫೋಟೋ ಕರೆಂಟ್ ಝೀರೋ ಮಾಡೋದಕ್ಕೆ. ಸೊ ಇವೆರಡನ್ನ ಡೈರೆಕ್ಟ್ಲಿ ಅನ್ಬೋದು ಸರ್ ಅಂತ ಅನ್ಬೋದು. ಡೈರೆಕ್ಟ್ ನೆಗೆಟಿವ್ ತಗೊಂಡು ನೆಗೆಟಿವ್ ಅಂದಾಗ ಅದು ನೆಗೆಟಿವ್ ನೀವು ಡೈರೆಕ್ಟ್ಲಿ ಅಂದ್ರೆ ಅದು ಕಡಿಮೆ ಅಂತ ಅರ್ಥ. ನೆಗೆಟಿವ್ ವ್ಯಾಲ್ಯೂ -10 1ಕ್ಕಿಂತ ಕಡಿಮೆ ಅದು, -10 -5 ಇವೆರಡ ಯಾವುದು ಕಡಿಮೆ? -10 ಕಡಿಮೆ, -5 ದೊಡ್ಡದು, -10 ಸಣ್ಣದು. ಸೊ here stopping potential it decreases with the frequency. So decreases with the frequency. ಹಂಗಾದ್ರೆ ಬೇಡ, ಕನ್ಫ್ಯೂಷನ್ ಆದ್ರೆ ನಿಮಗೆ ಕನ್ಫ್ಯೂಷನ್ಸ್ ಏನಾದರೂ ಆಗ್ತಾ ಇತ್ತಂದ್ರೆ ನೀವು ಈ ತರ ಹೇಳ್ಬಿಡಿ, ನಾನು ಪಾಸಿಟಿವ್ ವ್ಯಾಲ್ಯೂನಲ್ಲಿ ಇನ್ವರ್ಸ್ ಅಂತ ಹೇಳಿದೆ. ಇಲ್ಲ ನೀವು ದ ನೆಗೆಟಿವ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ರಿಟಾರ್ಡಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಫ್ರೀಕ್ವೆನ್ಸಿ ಜಾಸ್ತಿ ಇದ್ರೆ ರಿಟಾರ್ಡಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್ ಜಾಸ್ತಿ ಇರಬೇಕು. ನೀವು ಇದಕ್ಕೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಜಾಸ್ತಿ ಆದರೆ ಇದಕ್ಕೆ ನೀವು ಹೆಚ್ಚು ಮಾಡುವಂತ ನೆಗೆಟಿವ್ ಪೊಟೆನ್ಷಿಯಲ್ ಕೂಡ ಜಾಸ್ತಿ ಇರಬೇಕು, ಅಂದ್ರೆ ಮಾತ್ರ ಇದು ಝೀರೋ ಆಗ್ತವೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬರಲ್ಲ. ಇಲ್ಲದ್ರೆ ಹಾಗೆ ಬರ್ತಿರ್ತಾವೆ. ಯಾಕೆ ಬರ್ತಾವ? ಇದು ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಂದ್ರೆ ಜಾಸ್ತಿ ಶಕ್ತಿ ಇರ್ತದೆ, ಇವುಗಳಿಗೆ ಜಾಸ್ತಿ ಶಕ್ತಿ ಬರ್ತದೆ. ಜಾಸ್ತಿ ಶಕ್ತಿ ಬರೋ ನಾವು ಎಷ್ಟು ನೆಗೆಟಿವ್ ಆದ್ರೂ ಕೂಡ ಹಾಗೆ ಹೋಗ್ತಾ ಇರ್ತಾವೆ, ಮುಂದಕ್ಕೆ. ಸೊ this is what I am telling. Your frequency of incident radiation it depends directly on stopping potential. So as the value of frequency is more, stopping potential is also more. So you can see nu3 VO3, nu2 V02, nu1 V01, nu3 V03. ಇಲ್ಲಿ nu3 is a higher value compared to nu2 and nu1. nu1, nu2, nu3 frequency. So this is the graphical representation. ಅದು ಇನ್ನೊಂದರ ತೋರಿಸಬಹುದು. ನಾವು ಇದರಲ್ಲಿ ಇನ್ನೊಂದರ ಏನು ತೋರಿಸ್ತಾನ, ಇನ್ನೊಂದರ ತೋರಿಸೋದು ಇನ್ನೊಂದು ಗ್ರಾಫ್ ನಲ್ಲಿ ಏನು ತೋರಿಸ್ತಾನ, how the frequency depends on stopping potential. See, this is the graph of only frequency and we shall take frequency here, frequency this side and stopping potential. This is y-axis, this is x-axis. So ನೋಡಿ ಈ ತರ ವೇರಿ ಆಗುತ್ತೆ ನೋಡಿ, metal A and its frequency is nu naught, frequency is nu naught. So this is metal B, frequency is nu dash metal B. ಇಲ್ಲಿ ನೋಡಿ ಈ ಫ್ರೀಕ್ವೆನ್ಸಿಗೆ ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್ ಈ ವ್ಯಾಲ್ಯೂ ಬಂದಿದೆ, ಇಷ್ಟಿದೆ, ಈ ತರ ಇದೆ. ಅಂದ್ರೆ ಇದು ಒಂದು ರೀತಿ ಯಾವ ತರ ನೀವು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋಬೇಕಂದ್ರೆ ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಏನದವ ದೇ ಆರ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಒನ್ ಅನದರ್. ಬಟ್ ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅಂದ್ರೆ ನೆಗೆಟಿವ್ ಪೊಟೆನ್ಷಿಯಲ್ ಜಾಸ್ತಿ ಮಾಡಿದಾಗ ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್ ಬರುತ್ತೆ. ಸೊ ದೇ ಆರ್ ಡೈರೆಕ್ಟ್ ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್ and frequency they are directly proportional to one another. So as the potential stopping potential frequency ಜಾಸ್ತಿ ಆದರೆ ಇವುಗಳ ಒಂದು kinetic energy ಜಾಸ್ತಿ ಆಗುತ್ತೆ. So and you need to apply more negative potential to the plate A to stop the electrons which are coming from plate C to plate A. That's why I am telling you here frequency is directly proportional to stopping potential. If I am using a light of more frequency, then I should increase the negative potential of A to a larger value. If I am using a frequency of a light of minimum frequency, then I should say here no need to increase the value of negative potential of A. Smaller value is okay. If the frequency is maximum, here you should give maximum value of negative potential to plate A. If the frequency is minimum value of negative potential to plate A is sufficient. This is about effect of frequency of incident radiation on stopping potential. Directly, last point, directly proportional. If frequency ಜಾಸ್ತಿ ಇತ್ತಂದ್ರೆ ನೀವು ಪೊಟೆನ್ಷಿಯಲ್ ಕೂಡ ಜಾಸ್ತಿ ಮಾಡಬಹುದು. ಅಂದಾಗ ಮಾತ್ರ ಅದು ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅಲ್ಲಿ ಜನರೇಟ್ ಆಗುತ್ತೆ. ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅಲ್ಲಿ ಆ ಕಾನ್ಸೆಪ್ಟ್ ಬರ್ತದೆ. Right? So now I am going to tell you about experimental results of photoelectric effect. Experimental results of photoelectric effect. This is very important for knowledge as well as for your examination section. So up to last concept you were learning about photoelectric effect only. So now see, this is the time for what are the final conclusions about photoelectric effect. What are the final opinion about photoelectric effect? Okay, so see here. First one is see, photoelectric emission or photoelectric effect is an instantaneous process. Photoelectric, yes, what is the first point? Photoelectric emission. Photoelectric emission is an instantaneous. It is an instantaneous process. See here, photoelectric effect or photoelectric emission is regarded as an instantaneous process, immediate process, takshanada kriye. So here, why I am calling, why this is called instantaneous process means, here as soon as the light falls on the cathode plate or emitter plate, within the fraction of seconds, electrons are emitted from the cathode plate and they start moving towards the anode plate. So this is see, bell ಹೊಡೆದ ತಕ್ಷಣ ಮಕ್ಕಳು ಹೊರಗಡೆ ಹೋಗ್ತಾರೆ ಸ್ಕೂಲಿಂದ. ಊಟ ಅನ್ನ ಬೇಳೆ ಕಲಿಸಿದ ತಕ್ಷಣ ಊಟ ಮಾಡೋಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀವಿ ನಾವು. ಬಿಸಿ ಬಿಸಿ ಅನ್ನ ಬೇಳೆ ತುಪ್ಪ ಹಾಕೊಂಡು ಊಟ ಮಾಡೋಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀವಿ. ಫಿಲ್ಮ್ ಟಾಕೀಸ್ ಫಿಲ್ಮ್ ಬಿಟ್ಟ ನಂತರ ಶುಭಮ್ ಅಂತ ಬಂದ ನಂತರ ದಿ ಎಂಡ್ ಅಂದ ತಕ್ಷಣ ಎಲ್ಲ ಹೊರಗಡೆ ಹೋಗ್ತಾರೆ. ಇವೆಲ್ಲ ಇನ್ಸ್ಟಾಂಟೇನಿಯಸ್ ಪ್ರೋಸೆಸ್, ಅಂದರೆ ಇಮಿಡಿಯೇಟ್ ಪ್ರೋಸೆಸ್. There is no time lag, there is no much time difference between the two events. ನಾವು ಸ್ಕೂಲ್ ಬೆಲ್ ಹೊಡೆಯೋದಕ್ಕೂ ಮಕ್ಕಳು ಹೊರಗಡೆ ಹೋಗೋದಕ್ಕೂ ಟೈಮ್ ಡಿಫರೆನ್ಸ್ ಭಾಳ ಕಡಿಮೆ ಇರ್ತದೆ. Instantaneous process, this is called instantaneous process. So why it is called instantaneous process means time lag, time difference between incidence of radiations on the cathode plate and emission of electrons is about 10 to the power of minus 9 seconds. 10 to the power of minus 9 seconds. This is the minimum time, very minimum time. 10 to the power of minus 9. It is the smallest time. Microseconds, nanoseconds, nanoseconds. 10 to the power of minus 9 ಅಂದ್ರೆ 10 to the power nanoseconds ಅಲ್ಲಿ ಇದೆ. 10 to the power of minus 9, 10 to the power of minus 10 nanosecond ಅಂದ್ರೆ ಅಷ್ಟು ಕಡಿಮೆ ಟೈಮ್ ನಲ್ಲಿ ಎಮಿಷನ್ ಆಗುತ್ತೆ. So here, when the light falls on the cathode plate, within a fraction of a second, within this much of time, electrons are removed from the metal plate. So that's why this is called photoelectric emission is an instantaneous process. It is an instantaneous process. The second one for a given metal. So for the metal plate C, for a given metal, there exists a particular frequency of the incident radiation, below which there is no photoelectric emission. So here what I am telling, the light that we are using, this light, this is called incident radiation. So this must have a frequency. It must have a frequency below which, see, that frequency must be a standard frequency. That frequency must be a particular frequency, so that if you are using a light of frequency below the particular frequency which is called threshold frequency, the second result is about threshold frequency. It defines threshold frequency. What is a threshold frequency? Threshold frequency is the particular frequency of the incident radiation below which there is no photoelectric emission. ಆ ಒಂದು ಫ್ರೀಕ್ವೆನ್ಸಿಗಿಂತ ಕಡಿಮೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇರುವಂತಹ ವ್ಯಾಲ್ಯೂನ ಏನಾದರೂ ನೀವು ಬಳಸಿದ್ದೇ ಆದಲ್ಲಿ, ನೀವು ಬಳಸ ಲೈಟ್ ಅಷ್ಟು ಕಡಿಮೆ ಥ್ರೆಶೋಲ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಂದ್ರೆ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ನ್ಯೂ ನಾಟ್. Threshold frequency is new norm. Its symbol is new norm. So here for a given second first result idu immediate process annodu first on the conclusion result, final result of photoelectric effect. Second result it defines about the threshold frequency. ಏನು threshold frequency ಅಂದ್ರೆ ನೀವು ಈ ಲೈಟ್ ಅದ ಇಲ್ಲಿ ಲೈಟ್ ಆ ಲೈಟ್ ಇರಬೇಕಾದಂತಹ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಫ್ರೀಕ್ವೆನ್ಸಿ, ಅಷ್ಟು ಫ್ರೀಕ್ವೆನ್ಸಿಗಿಂತ ಏನಾದರೂ ಕಡಿಮೆ ಇರೋದನ್ನು ನಾವು ಉಪಯೋಗ ಮಾಡಿದರೆ, ಕಡಿಮೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇರುವಂತಹ ಲೈಟ್ನ ಉಪಯೋಗ ಮಾಡಿದರೆ ದೆರ್ ಈಸ್ ನೋ ಫೋಟೋ ಎಮಿಷನ್. ಅಲ್ಲಿ ಯಾವುದೇ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಎಮಿಷನ್ ಆಗಂಗಿಲ್ಲ, ಎಲೆಕ್ಟ್ರಾನ್ ಎಮಿಷನ್ ಆಗಂಗಿಲ್ಲ. ಸೊ ದಟ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಫಾರ್ ವಿಚ್ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಎಮಿಷನ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಥ್ರೆಶೋಲ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ. ಅದೇನಂತ ಕರೀತಾರ? ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಥ್ರೆಶೋಲ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ. ಸೊ ಥರ್ಡ್ ಪಾಯಿಂಟ್, ಥರ್ಡ್ ರಿಸಲ್ಟ್ it says about the intensity of the incident radiation and photocurrent. So here intensity of the incident radiation is directly proportional to, see, intensity of the incident radiation, it results in the maximum value of photocurrent. If this light is having more intensity, then the electrons which are inside the metal plate, they gains more energy from the light and they easily escapes from the metal plate C. So what it means here, the emission of more electrons from the metal plate C, it depends on intensity of the incident radiation. More the intensity, more number of electrons emitted from the plate C. Lesser the intensity, lesser number of electrons emitted from the plate C. So here one thing I can tell you, intensity it increases the photocurrent, intensity it decreases the photocurrent. So photocurrent is directly proportional to, third point is photocurrent is directly proportional to intensity of incident radiation. Intensity of incident radiation. So here the photoelectric current is directly proportional to intensity of the incident radiation. If the intensity is minimum, photoelectric current is minimum. If the intensity is maximum, photoelectric current is maximum. This is the third experimental result of photoelectric effect. Fourth one, the kinetic energy of these photoelectrons. The maximum kinetic energy means speed. The speed, as I see, this is already explained in the last concept. That's why I am moving fastly. So you can refer to last concept and understand. So see here the maximum kinetic energy of photoelectrons, it depends on frequency. As I told you, frequency gives more energy for the photoelectrons to move from C to A. So fourth point is maximum kinetic energy is directly proportional to, frequency of incident radiation. Here the maximum kinetic energy is directly proportional to frequency of incident radiation. If the frequency is minimum, the kinetic energy obtained for the photoelectrons is minimum. If the frequency is maximum, kinetic energy is maximum. The last point, fifth point is same thing. When the plate A is made to have, negative potential potential, if the potential of plate A and plate C are reversed, if the initially plate A is having positive potential, plate C is having negative potential. When anode is made negative, here concept is when anode is made negative, when anode A, anode means collector plate, when anode is made negative, so what happens? As you know that what happens here, if anode plate is made to have negative potential, then it starts repelling the photoelectrons. So photoelectrons now they start repelled by the plate A. They are not further attracted towards the plate A. So the number of photoelectrons which are coming from C to A decreases. The number of photoelectrons which are coming from C to A decreases, but only the electrons which are having more energy, they only comes towards plate A. But if you still increasing the negative potential to the plate A, so even the highly energetic electrons also not able to reach the plate A. So thereby photocurrent becomes zero. The number of, first of all, the number of photoelectrons decreases which are coming from C to A decreases, and thereby photocurrent also decreases, but not it does not becomes zero immediately. Still even few 2 to 3 to 5 photoelectrons which are having greater energies, they move from C to A and they result in photoelectric current, but that photoelectric current goes on decreases. For a particular value of negative potential, given to the plate A, the photocurrent becomes zero, and that negative potential given to the plate A is called stopping potential. Stopping potential. So first definition first experimental results instantaneous process ಬರಿಬೇಕು. Second one threshold frequency ಬಗ್ಗೆ ಹೇಳಬೇಕು. Third one dependence of intensity and photocurrent ಅದರ ಬಗ್ಗೆ ಹೇಳಬೇಕು. Fourth result how the kinetic energy depends on frequency ಅನ್ನೋದನ್ನ ಹೇಳಬೇಕು. Last point what happens when anode is made negative ಅನ್ನೋದರ ಬಗ್ಗೆ ಹೇಳಬೇಕು. So today only you read the notes. So now I am sending this chapter notes to your group, so you can look after the concepts, and today only you read these concepts and practice. Okay, this is very important for 5 mark section. So keep watching my class videos so that you can understand more things about dual nature of matter and radiation. So watch this video for 2 times. Have a nice day. Tomorrow I am starting a new concept of this chapter.